So I started my career in the mid-1970s when I did my PhD, believe it or not, on medical diagnostic systems. Eventually, it turned out to be 5 different publications on a wide variety of algorithms because I'm a mathematician. I'm not a computer scientist, and it had to do with how do you measure the information content in a given test, how do you calculate probabilities of multiple disorders, and those of you who are interested in this old work, search Google under the term MEDAS, MEDAS, and I assume we'll find some of my publications from the early 1980s. Right after my PhD, I moved to USC, University of Southern California, and on, when I look back into my life, it's been like 20 some years in Israel, 20 some years in the United States, and you never know when you are. In any event, after quite a long academic career, in 1998, I founded Click Software, following the invention of what we call service chain optimization. I assume many of you know the term supply chain optimization from the manufacturing world. So we invented this term, optimizing service operations using AI technology. We founded the company Click Software in roughly 1997, grew up real quick, and by 2000, we were already a public company. I was the CEO of this company since we started it until 2015. From its very beginning, it was always the market leader in this space and grew and grew and grew until last year, Salesforce, the company Salesforce from the United States, acquired Click Software for $1.4 billion, which was a very nice achievement. Over the years, I went through a transformation, which is very interesting, from being a mathematician, academician, scientist, not even business academician. But when I started the company, I learned that the business is much different than mathematics, and I had to learn it. And I learned a lot, and all my lessons eventually got packaged into what I call business capsules. And these are business capsules that are eventually, last year, I turned them into a 1 full semester class at IDC, where I taught a class called the Startup Scale Up Masterclass. And essentially, it takes a combination of all the practical mistakes I did and all the lessons I learned and how to grow startups. So if any of you would be interested in this in Denmark, I would be more than happy to offer some of these workshops in Denmark as well. Right now, I'm semi-retired. I share my life in doing some algorithms, doing some business consulting, investing in startups, and so on and so forth. In any event, the title of my talk is Practicing Business AI. First, because there are so many applications to AI which are not necessarily classic business decision making. I like to focus on business applications, and I like to focus on how to practice them. And I will use one example of application to manufacturing. And if we have time, then I can also give you some example of traffic management in the city traffic management, with some examples of 2019, a company I invested in has done a very nice job in the United States Super Bowl in Atlanta last year. In any event, so it's a pleasure to be here, and the way I structured my presentation is in 10 points, and because time is short, we only have about 20 minutes, and that's what I would like to do. So point number 1, the first spring of artificial intelligence was from roughly early 1980s to mid 1990s. And then we went into a winter that lasted almost 10 years. And that was because there was some disappointments into all sorts of promises by neural networks technology and the like. Although it did not stop. In fact, Click Software is one giant artificial intelligence engine that, of course, eventually, as you heard, it still dominates the world. I mean, service optimization is still dominated by Click Software. In any event, in the mid So in the early 2000, 2005, 2006, a new spring started following really dramatic and fantastic breakthroughs in what I call data-centric machine self-learning algorithms. And every word counts here. The AI, as most of you know it today, assumes that you have tons of data for a certain topic, and you apply deep learning or some other data science technologies, or so that the machine self-learns something, and then you deliver the output. Example, medical image interpretation from X-rays to ultrasound, of course, EKG interpretation, or natural language agents, or customer churn prediction. And on purpose, I took applications from different areas, but quite frankly, when you dive deep into it, you see that they're all using very similar algorithms, and they all rely on intensive data, tremendous amounts of data. And as a result, current AI applications, as we know them today, are called narrow AI because they address a limited scope of the workflow of a business user. If you take face recognition, you can buy in the market a product for face recognition, and people can use it in a wide variety of applications, such as safe city professionals, or you can do this in checking at airports, or you can do this in for police applications. It's the same algorithm that you use for different applications, but the AI part of it, it's really a black box, like EKG interpretation, as an example, okay? You take an EKG, the black box processes the classification, and it tells you, for instance, diagnosis ST changes. This AI application knows nothing about anatomy and physiology and the way the eye operates and the meaning of the electric signals. All it knows, and I would say it's quite primitive, all it knows is to recognize shapes. We gave them 50, 60,000 EKG signatures that physicians classified by the roughly 9 to 11 categories. And we apply deep learning, and bingo, now you give it a new EKG, and it tells you that it belongs to category 1 or category 2 or category 9. But this machine knows nothing about medicine. Clearly, all of you would agree that a physician, a cardiologist, does many other things, and there are many other decision-making tasks before and after the EKG step. And that's why an AI solution that only offers EKG interpretation is very narrow. Roughly about a year ago, I wrote an article, and you have the linkage here. It's called Disease Labeling via Machine Learning is not quite the same as medical diagnosis. So if you see titles in some Wall Street or New York Times, AI doing medical diagnosis, check carefully if all they do is they give a label to a signal or give a label to a patient. And as I explained in this article, it's not the same as medical diagnosis. Medical diagnosis is much richer and complex decision making. In any event, my claim is that if we develop AI solutions that cover the entire workflow of a business user, if we take again the medicine example, from the moment a patient steps in until it checks out of the whole process goes through, you ask about initial complaints, you send them to the blood test or X-ray, and how do you decide about that? You get this results back, and you make some other decisions, and then you proceed into treatment, and then and on and on and on. If we succeed in developing a product that serves as a companion to the decision maker throughout the workflow, throughout his full day, okay, that's where you get much, much higher value. To do this, you really have two main sources to achieve this value. One is the level of intelligence, namely the output quality of the EKG interpretation, or recommending the next step, or actually doing the diagnosis. That's, of course, if it's not there, then there's not much. This is not AI, okay? On the other hand is the level of automation, and I will illustrate this shortly in a manufacturing application. Namely, to what extent the work of this doctor is becoming now more and more automated, and he's not concerned about all sorts of mundane work that he should not really be doing. What you see to the right is what I call the AI quadrant. Even though I'm a mathematician and I'm a scientist, I approach AI in a very pragmatic manner. And Turing test is a great an intellectual test. But in terms of business AI, I say AI of system 1 is greater than AI of system 2 if it generates more value. And the value really comes from this level of intelligence and level of automation. The more you are to the top right, the more intelligence you have. And in this article, you have the link below there. I describe this, this notion of AIQ, the AI quadrant. One chart that I'd like you to take away when you talk about business AI is the following. As computer intelligence increases, first, the dependence on user skills, domain knowledge, and experience decreases. For instance, okay, years ago, I developed a tool to support technicians in troubleshooting equipment. And the moment this tool starts performing in an expert level, you no longer depends on if this technician is smarter, high smart, very intelligent, does he know very well the equipment, how much experience he has. Right away, the dependence on the individual goes down. And if you do this AI right, then you actually produce a team of a user and AI that produces better decisions than any one of them individually. And then, as I said before, user spends less time on mundane tasks and gets faster what he needs to accomplish on his job. Overall, the productivity of this man-machine team is higher and the business value is higher. So that's a very important takeaway chart that I'd like you to remember. Years ago, I still recall in my early days, like books where what computers can do, what computers cannot do, and this continues up until today. And I say, guys, this is the wrong question. We should not focus on what computers can or cannot do. We should focus on whether we can build a man-machine team, part to use human intelligence, part to use machine intelligence, but together they produce a solution, decision-making that is better than any one of them individually. Because we all know business AI, it's all about the value it generates. We are not interested in intellectual questions, not in business. I mean, it's okay for parties, but in business, does it produce value? Does it increase my customer satisfaction level? Does it reduce my expenses, and so on and so forth? So you may ask, so why is that most current AI applications we are seeing are point solutions? Why don't we see broader solutions? By the way, with all due modesty, the products of Click Software are very broad. They cover the entire decision-making process in a service operation, starting with appointment booking to promise to the customer what time a technician will arrive, going into automatic scheduling in the morning, going into real-time re-optimization during the day, going into planning and forecasting. The entire decision-making of the organization is being supported by an AI engine. You don't see many of these type of solutions in the market today. Most of them are very narrow solutions. Why is that? First, because this winter that we had in the late 1990s and early 2000s, people do not really know how to do this. But most on the positive side, new data-centric techniques, and people today are primarily applying data-centric techniques and believe that data only, no human touch, black boxes, fully self-learning by the machine. In my opinion, that's wrong, because business workflows require deeper knowledge and problem-solving algorithms, and you've got to have sometimes user in the loop. I do recall, I'll give it this in a very brief manner. I do recall the following example, which is it's a real one, but I will save you the details. So picture two analysts sitting in Washington, D.C., receiving pictures from the Middle East, and in the picture there is a vehicle, and they have tremendous, fantastic, powerful deep learning algorithm to classify whether this vehicle is a military vehicle or is an agricultural vehicle. And the computer came out with 49% agriculture, 51% military, which of course doesn't help much. So Jack and Jean, okay, the two analysts are sitting, looking with their eyes. Now, both of them are very experienced analysts and are looking at it and arguing and cannot make up their mind. Somebody knocks on the door. Jean say, "Come on in." And then John joined them, and he comes from finance and in the defense department, and he just well, Jean is his friend, and he asked Jean. He wanted to ask Jean if she would like to go to lunch, and Jean said, "Be quiet for a second. We are in something very deep." And so he's good old friend, so he stayed on the side and he listens to them when they argue between them whether this vehicle is an agricultural vehicle or military vehicle. He approached the picture and say, "Guys, can I help you?" And they say, You are from finance department. How can you help us?" Say, "Guys, this is not an agricultural vehicle." And he say, "How do you know?" And he say, "Because I'm a farmer from Nebraska." Now, so he applied knowledge that is not in the picture. He applied what I call domain knowledge. AI systems as they are being built today by most people do not involve domain knowledge, and that's a pity, because if you do involve domain knowledge, as I will show you in a second in some manufacturing applications, you do increase what you can do with AI. Again, on this, there was an article I wrote, I believe 2017 or 2018. It's called Wikipedia for Smart Machines and Double Deep Learning. And essentially what I said, in addition to giving computers tremendous amount of data and applying deep learning on the data, how about equipping computers with Wikipedia? The entire human knowledge that got accumulated over thousands of years, like anatomy, physiology, and medicine. Why not store it not as articles, store it in structures like transition state diagrams or whatever we use in computer science to encapsulate human knowledge. This is not data, this is knowledge. Okay, now you may say, what's the big deal? Why don't people do this? And this may sound easy to fix, but you first need to have AI as a state of mind, and that's my next point. Sometimes you go into a demo of software and I diagnose it right away, whether it's an AI software or just people claim to be AI powered software. And I'll give you the secret. The way to diagnose whether software is AI or very limited AI is if during the demo you keep hearing something like, at this point, the user navigates here, and then that user may now request this dashboard, and the user, and it keeps saying the user, then you know that it has very minimal AI. Let me give you an example from city traffic management. I was approached by the founders of this company, this was 2-3 years ago, and they showed me a demo. They developed a fantastic software with dashboards you can't believe and all sorts of traffic indices in it. And they started the demo by saying, okay, it's morning, and the traffic manager is logging in, and he say, okay, show me the traffic coming into the city in junction A. And the computer right away display fantastic graphics and indices. And then say, could you please show me the traffic from junction B? And he shows it. And I say, yeah, but overall, what's the load in the middle of the city? And they keep telling me, and the user now asks this, and the user now asks that. And then I ask them, guys, why is the user asking all these questions? And they say, because he would like to know how to set the traffic light speed, the change from red to green to yellow in different parts of the city. And I say, if this is the purpose, how about building software that when he logs in, it is the computer who initiates proactively. And he says, look, we have a problem in junction A and in junction B, and here are the indices. And now I suggest that you change the traffic light as follows. How about that? This is called AI at its best. And this company called Mobi is now quite exciting and is doing fantastic projects in Israel now, specifically with the COVID complications of the traffic management and in the United States. But what you see there, you see a software that the computer, the AI algorithms are kind of continuous companion to the user, and they keep coming up with ideas and like they're part of the team. So as you hear more about proactive involvement of the software in the problem-solving dialogue, not just data analysis, with automatic solutions, initiating, that's when you know that you have an AI which is really strong AI. Let me now show you an example from a company that I founded it many years ago, but now it's run by my son. So, kind of fair disclosure, I love this company, and I myself still very much involved. And what I'd like to use one example. Okay, in the story I'm now telling you appears in the text of the next chart. I wanted to just kind of keep this chart not too overloaded. So we have an aerospace company. They produce, let's say, wings of aircraft, and for this purpose, they use composite material. Just to cut the long story short, composite material, as you know, have expiration date, and if you take them out of the freezer and they stay out for too long, the expiration date gets too short. So picture a situation where a message is sent into this company, and the message say it's from one of their suppliers, and you say, I apologize, I'm sorry, but roll number 216 that I sent you some time ago, we discovered a defect, and that's why everything you produce from this roll just go by your procedures. For those of you who are not from aerospace, you cannot send to Boeing a wing that is not absolutely perfect from very strict QA rules. So at this stage, this company has now got to look into what was produced from this roll, check what are the urgent things to do, reschedule how to fit them into today's schedule if they have to go tomorrow, and in parallel, they have the ongoing today's schedule and what's going on. Normally, without the tool I will be describing now, this can take hours to recover from this seemingly simple message, the roll number 126 is faulty. Platane it's called total production optimization. It's an AI engine that literally, I will now show you the dialogue with the software. In 2018, Wired Magazine wrote something about it because we interfaced this software with the Google Glass. And in the Google Glass, the plant manager could walk around with his Google Glass, and the AI was kind of communicating with him in the Google Glass. Now listen to this, okay? What happened when this message from the supplier just arrived? The computer now some display on the Google Glass tells the, now look into the sequence of decisions. Note the sequence of decisions that this computer took without asking anyone any questions. Okay, so the computer says, we have just been informed that composite material roll A784 is defective. We manufactured the following 15 kits from the roll. Look, the user did not have to ask, tell me what we manufactured. It knows it's important, so it's initiating it. And now we need to remake them. The specific rolls to pull from storage rooms are also included, taking into the consideration expiration date and the like. So on the display, the user will see, I now suggest you take roll X or roll Y. And then the computer tells the user, upon your approval, I will also automatically produce the nesting. And in parallel, you also went on and schedule it automatically. And what used to take hours is suddenly being resolved in minutes. So this is AI state of mind. It's a man-machine team that every one of them plays a role where he has relative advantage over the other. So we're talking about a fully connected, intelligent digital factory. Everyone, the point of view of the man-machine user, everyone does his job, and eventually you get the quality of the decision-making, the level of automation, and overall productivity goes up. Okay, that's just a summary of what I said before. So when you combine AI and IoT, we place sensors all over the manufacturing plant, and by getting this data, we really create the so-called manufacturing operations management with lots of automation, and that's what everybody is talking about, Industry 4.0. The customers who are using it today are General Electric, Boeing, Airbus, the Chinese Comac, and a few others. Now I'd like to talk, for those of you who are technologists, about the notion of product management if you'd like to have AI state of mind. Normally, when people go about writing software, there is a role called product management, and one of the most fundamental things in this technique is the so-called user persona. And if you are going to write, let's say, software for bankers, you go and analyze a banker workflow and you start developing software for this guy. And they, do the workflow. They produce screens of the picture of the screenshot that he will go through, and so on and so forth. The secret for doing AI is it starts with product management to specify the software. You've got to understand that there are two personas. There is the human persona, which we will call user persona, and there is the AI persona. And as the workflow proceeds, each one of them has a role. And you have to decide, that's the product management level, which part will be done by the user, the human user, and which part will be done by the machine, and how they are going to communicate to make sure that they do better than any one of them individually. So that's the secret of doing really AI as a state of mind. Another important element of business AI is the time horizon. We all know it's never the decisions which are 7 minutes ahead or those which are 7 hours ahead. If you want to be successful, you have got to design decision-making support tools for the entire time horizons of your business. And we don't have time to go over it today, but keep this in mind. As I was developing my softwares over the years, and this include many defense applications from the early 1980s for DARPA, NASA, NIH, NSF in the United States, and the Defense Department in Israel. And as was mentioned before, I came back from the US after several years, and this was 1980s, and everybody was concerned, well, we don't have AI, and everybody is talking about AI. This is the first spring, and this is when we started the AI Association of Israel, and teaching classes, developing software and the like. And over the years, I learned that decision-making in life, really we have, almost in everything in life, we really have a cycle that routinely goes on. Every so often, we say, okay, where we are, and then where we are heading, and then what to do about it. Shortly, I will give you examples from business, but let's just take a quick example from life, okay? Just picture a young executive, very senior level, who is now going by his daily schedule in business. One after the other, line up meetings. Suddenly his wife calls and let's say, Steve, I have a problem. I'm stuck in traffic and I am about to pick up Jack, our son. And as I look into the traffic report, there is no way I will be able to pick him at 4. It's now already 3:30, and I'm stuck. I also checked and I realized that traffic from your end, maybe you can help. Now, forget about what's the right decision to make. Let's analyze it. Okay, so Jack now has where we are. Okay, I have meetings with a very important customer who flew all the way from New York to see me. Wow. Where are we heading? If I do nothing, my son is stuck at his basketball practice. If I leave now, my customer is going to suffer. So I have to analyze where are we heading if I do nothing. And then once I decide, I have to say, okay, what to do about it. Maybe I will hire a driver or I will send a taxi to pick up my kid or whatever. Okay. Now you see this in every day of life in business. If I go back to the role, okay, so we were running a certain day on the manufacturing floor. Suddenly a message comes, roll 148 is damaged. If I do nothing, a faulty wing will be sent to Boeing. That's a disaster for the company. So you have to analyze context recognition and context situation assessment. And then what will happen if I do nothing? What will happen, the cost, and then what to do about it. This is really the name of the game in building business AI. And surprisingly, the algorithms are totally different. It's no longer the deep learning algorithm necessarily that will do this. For instance, in search optimization, it's totally different algorithms. Some prediction forecasting is not deep learning, some others. Deep learning, it's okay, but whatever, you need to be good at a wide variety of algorithms to really address this continuous three stages cycle. And that's what I do mostly when I do the business AI solutions. Chart number 9 that you see here gives you some more data for after the session, and I explain a little bit about it. I never published it, just I guess was too lazy, but I practice it. I've been practicing it for many years, and it worked for me beautifully. So summary. Okay, first, the name of the game is creating a winning AI product is to keep asking how to increase participation of the AI software in the solution process of the given business problem, namely increase the level of automation. But of course, you have to do this with quality results, how to increase the quality of the end results. For example, in the Click software, the schedule of the day is very critical to determine the quality of customer satisfaction, customer service, and of course, the efficiency of the operation. If you schedule a technician to go uptown, downtown, and back uptown, maybe he will do 2 jobs per day. If you schedule him optimally like we do, maybe he will do 4 jobs a day. And here you see again a metric. I take a schedule of the organization before I approach him. He gives it to me and I say, on average, they do 2.7, 3.0, something like this on average. I take his data, I run it through the optimization algorithm, and I show him that he can do 4.6 jobs per day. Well, clearly, using the AI quadrant, he can calculate the value of this and whether or not to buy the software. But that's a key point I want you to take. Don't worry about fully a kind of black box solution that can do everything by themselves. This can be done for face recognition or for handwriting recognition or for signature recognition. If you want to do a business AI of decision making, this is where most of the money and gains are. I recommend you keep asking yourself, okay, how can I increase the involvement of the computer in the decision making processes? So in summary, AI is the software industry of the future. Namely, it's no longer a specialty. Any software operation companies who will not have AI deep as a state of mind will be inferior. They will not be able to compete because in everything there will be this thinking what else machines can do. And that's what I would recommend to you guys. Again, I was a contributor to the machine learning algorithms. You can check on my old publications. I have the entire respect for them. As I said in chart number 1, this really are the key factor that drove AI back into the renaissance that we are experiencing today. But we must not stop there. We must not believe that data-centric only AI solutions will do the job. We can do much better by integrating domain-specific knowledge. I gave here 3 references to some of my recent works, and of course, there are many other articles, but this will give you the background you need for the yeah. And